Big savings ahead! Well, hello there. Richard Trethaway here. Today we're tackling a big job that can save you some serious money. We're talking about rewinding an industrial motor. This is a 5 kilowatt motor, a real workhorse. When these things fail, many folks just buy a new one. That can cost you thousands of dollars easily. But what if I told you there's another way? A way to get that motor humming again for a fraction of the cost. That's right, we're gonna rewind it ourselves. The biggest reason to do this? The savings, of course. A new motor like this could set you back, say, $3,500 or more. The materials to rewind it? We're talking a few $100s. That's a potential saving of over $3,000. Think about what you could do with that kind of money. Plus, there's a real satisfaction in fixing something with your own two hands. You're not just saving money, you're learning a valuable skill. And you're keeping a perfectly good motor casing out of the scrap heap. That's good for your wallet and good for the planet. Now this isn't a 5-minute job, it takes patience and attention to detail. But it doesn't require a fancy engineering degree. Just some basic tools, the right materials, and a willingness to learn. Let's get started on this rewarding journey and get this motor back in service. Alright, let's take a look at our patient. This here is a 5 kilowatt 3-phase industrial motor. It's been working hard, but lately it just gave up the ghost. The owner told me it was running hot, making some funny noises, and then it tripped the breaker and wouldn't start again. These are classic signs of a problem with the motor windings. When a motor like this fails, 9 times out of 10, the windings are the culprit. They are the copper wires inside that create the magnetic fields to make the motor spin. Now if you look closely here, you can see some telltale signs. We've already taken off the end bells and pulled out the rotor. Peeking inside the stator, which is the stationary part, you can see the windings. Some of the insulation around the copper wires looks dark, almost charred in places. You might even smell a distinct burnt odor. That smell is a dead giveaway. It means the insulation got too hot, broke down, and the wires shorted out. This motor has definitely suffered a burnout, so our diagnosis is clear burned out windings. The motor's bearings might still be good. This is exactly the kind of situation where rewinding makes perfect sense. Before we even think about touching those old windings, let's talk safety. This is the most important step in any job, especially when you're working with electrical equipment and tools. Number 1, make absolutely sure the motor is disconnected from any power source. Unplug it. If it's hardwired, turn off the breaker and use a lockout tag. You don't want any surprises. Double check with a voltmeter if you're unsure. Safety glasses are a must. When you start pulling out old wires and cleaning things up, bits and pieces can fly. You'll also want to wear some good work gloves. Those old windings can have sharp edges, especially if the insulation is brittle and flaking off. And the stator housing itself can be rough. A good pair of heavy-duty gloves will protect your hands from cuts and scrapes. If you're using any solvents for cleaning, make sure you're in a well-ventilated area. Read the instructions on those products carefully. Some fumes can be nasty, so a respirator might be a good idea, depending on what you're using. Another thing to consider is the weight of this motor. A 5 kilowatt motor isn't a lightweight. Be careful when you're moving it around or turning it over. Okay, safety gear is on, power is off, we're ready to start the demolition phase. This means getting those old, burned out windings out of the stator. This part can be a bit messy, but it's crucial to do it carefully. The first step is usually to cut the end turns of the coils. These are the parts of the windings that loop around outside the stator slots. You can use a good sharp chisel and a hammer, or sometimes an angle grinder with a cutting disc, if you're very careful not to damage the stator laminations. Once the end turns are cut on one side, you'll need to remove the slot wedges. These are insulating pieces that hold the wires down in the stator slots. They can be made of fiber, wood, or a composite material. You might need a thin drift punch and a hammer to gently tap them out. Take your time here. You don't want to gouge the inside of the stator slots. The condition of these slots is important for the new windings. Be methodical, working your way around the stator, removing all the wedges. With the wedges out and one side of the end turns cut, you can start pulling the old copper wires out from the other side. Try to pull them out as cleanly as possible. Section 5. Prepping the stator, cleaning and insulating for a fresh start. With all the old damaged copper windings removed, the stator is looking pretty empty. But we're not ready for new wires just yet. The next critical step is to thoroughly clean and prepare the stator core. Those slots where the windings sit need to be perfectly clean. Any old bits of insulation, varnish, or burnt residue must be removed. You can use a variety of tools for this: small files, wire brushes, or even specialized slot scrapers. The goal is to get back to the bare metal of the laminations, but without damaging them. Once the slots are clean, inspect them carefully. Look for any sharp edges or burrs that could damage the insulation on your new wires. If you find any, smooth them down gently with a fine file. Remember, the stator core is made of thin sheets of steel called laminations pressed together. You want to avoid separating these or bending them. A smooth, clean slot is essential for a long-lasting rewind. This is also a good time to clean the entire stator housing, inside and out. Get rid of any dirt or grease. Now here's a really important part: insulating the slots. Section 6. Winding anew, crafting and installing the new copper coils. Now for the part that gives this job its name: winding the new coils. This is where we take fresh, new magnet wire. That's copper wire with a special enamel insulation coating, and form it into the precise shapes needed to fit into our prepared stator slots. You'll need to know the correct wire gauge, or thickness, and the number of turns per coil. This is the information you hopefully gathered when you remove the old windings. If not, you might need to find a motor winding data sheet for your specific motor model, which can sometimes be tricky. You can wind coils by hand, which is very time-consuming for a motor this size, or you can use a coil winding machine. These machines can be simple hand-cranked jigs or more sophisticated automated ones. For a 5-kilowatt motor, a dedicated winding machine, even a manual one, makes the job much more consistent and manageable. You'll set up the machine to the correct coil span, which is how many slots the coil skips, and shape. Section 7. Finishing touches: connecting, lacing, and varnishing. With all the new coils carefully placed in the stator slots, the next big step is connecting them correctly. This is where your notes on the original connections become absolutely vital. The coils need to be connected in series or parallel, and in the correct phase groups to create the rotating magnetic field that makes the motor run. This involves stripping the enamel insulation from the wire ends, making solid electrical connections, often by brazing or using high-quality crimp connectors, and then insulating each connection thoroughly with heat shrink tubing or specialized insulating tapes. After all the internal connections are made, the end turns. Those loops of wire at each end of the stator need to be neatly shaped and secured. This is called lacing. Using a strong, heat-resistant lacing cord, you'll tie the coils together and to supporting rings if the motor design includes them. Proper lacing prevents the wires from vibrating, which could lead to insulation wear and premature failure. Section 8. Power up, success, savings, and your next project. Alright, the moment of truth has arrived. We've got our rewound stator freshly varnished and cured. We've reassembled the motor, put the rotor back in, attached the end bells, and made sure everything spins freely by hand. Now it's time to connect it up and see if all our hard work has paid off. We'll connect the motor leads to the power supply, making sure all connections are tight and correct for the voltage we're using. And of course, we'll have an ammeter connected to monitor the current draw when it starts. Here we go. We flip the switch and listen to that. It's running smoothly, just like a brand new motor. No strange noises, no excessive vibration. That's the sound of success. We'll let it run for a bit with no load and check the ammeter reading. We're looking for balanced current across all 3 phases, and the current should be within the motor's rated no-load amperage. If the readings are good, that's a fantastic sign that the rewind was done correctly. In this case, our ammeter is showing a healthy, balanced current. Perfect. Think about what we've accomplished here. This 5-kilowatt motor was destined for the scrap pile.